What is the special theory of relativity? This is a theory which describes the most basic yet unimagined phenomena on which we are going to talk in today's video. To understand the special theory of relativity, we need to be familiar with the two postulates of the theory. Let's start with the second one, as it is much easier to understand. We will cover the first one in the next video in detail. The second postulate says that the speed of light is constant for all observers, irrespective of what speed they are traveling with.
Okay, let's make it easier for you by understanding relative motion and frame of reference approach. Imagine you are traveling in a car, you see your friend standing roadside and you both wave at each other. As you are in the car, your driver is stationary for you, but your friend seems to appear moving away from you. While from your friend's point of view, you and your driver are moving away and not him. The scientific word for this point of view is the frame of reference. As the name suggests, it is any frame that is taken as a reference. From your frame, the friend is moving, and from your friend's frame, you are moving. Driver's frame is in the same velocity as yours. Such type of frames are known as inertial frames. Hence, drivers appears to be stationary to you. Consider another simple experiment. Two astronauts, Alex and Bob, both are in a region of space where no other things are available, not even stars or any planet. We should ignore the reason for how and why they reached such states, but just take it for granted. Now Alex and Bob both have a torch and they light it up against each other, but they find that they are moving close to each other. Now what do you think? Is it Alex moving towards Bob? Or is it Bob moving towards Alex? Or is it both moving towards each other?
Well, the answer is pretty simple. You can't tell. All you can say is that there is a relative motion between them. From Alex's frame of reference, Bob is moving towards him and vice versa. Similarly, for two bikes moving parallel to each other in the same direction with 10 km per hour respectively, each one of them individually would see other to be stationary. Coming back to our postulate, this doesn't apply to light. If we have two light beams approaching parallel to each other with velocity say c in the same direction, and suppose you are sitting on one of them and observing the other, you will still observe the speed of the other beam to be traveling at c and not stationary. Why? Because of time dilation and length contraction, about which we will be talking individually in the upcoming videos.